Go, sir. And the last question, thank you all for coming after this, yeah.
I'm also a big fan of Star Talk, and a couple of months ago, you had thrown a fact out there about black holes, and that a black hole the size of a quarter could actually devour the Earth-sized planet, an Earth-sized planet.
Oh, easily.
And I've heard you talk about black holes a lot.
Have you not slept well since then?
No, it's not that. It's not that. I would like to know what that would look like. Would our atmosphere be the first thing to go? Would things become oblonged and sucked into it like what you imagine, or would it break apart? Just,
I mean, how do you get something the size of the Earth to fit into something the size of a quarter? Yeah, so I recently a year ago I tweeted, we have these things called pulsars, which are very dense matter. It's like the densest matter there is before you collapse into a black hole. So to put that in context, how dense this material was, I said, take a herd of 50 million elephants and cram them into a thimble. Then you get the density of the material on a pulsar. So in other words, scoop up a thimble's worth of pulsar material, put it on a scale, on a balance scale, and then I say, what do I have to put on the other side here to balance that thimble? I have to put 50 million elephants here. So that's an extraordinary extreme of nature. In fact, in my field, we have to be parsimonious with our descriptive adjectives. I can't say Jupiter's gigantic. Well, it is compared to Earth, but it's small compared to the sun. I can't say the sun is gigantic. Well, it can hold 1 million Earths if it were hollow, but Betelgeuse can hold 1 million suns. Okay, so when do you say something's big and huge? So I try to, but now we're at the limits and I get to say this is an awesome number of elephants to fit into a thimble, okay? So now you go denser than that, this thing collapses into a black hole, and no matter the size of the black hole, it's going to eat anything that comes near it. So Earth would slowly sort of, what would happen if you drop the black hole, Earth and the black hole will drop towards one another. Okay? And Earth will begin to funnel down towards it. And so basically Earth will begin to crumble as it gets ripped apart and it gets stretched, spaghettified. It's the act of spaghettification that occurs because the black hole is small and what it's eating is large. And that's what happens in a spaghetti machine. There's a tiny hole and a big blob of dough, and at the end it's a spaghetti stream. So it would not be pleasant. It would probably happen very fast, faster than you can communicate this information to the other side of the world. So just enjoy it as it happens. It's a one-way. We're pretty sure we've got the inventory of black holes figured that this is not the most likely way to die. But it'd be an awesome way to die. By the way, this ripping apart into a strand, the two things that are happening is ripping you head to toe, Earth head to toe, and the funneling is another interesting feature because the space-time that it occupies is this tiny little narrow funnel, essentially. And that's where you get, that's the concept of spaghettification. And I wrote a book, Death by Black Hole. Oh, she has the book right behind you, see? Yes, Death. Vanna White, thank you for displaying. And in there, I describe in detail what would happen if you personally fell into a black hole. And yes, it's a one-way trip, but it's awesome, and it's my choice of death. Like if I want death row, I said I want to die by black hole. If I had the choice. But it's much better than getting hit by a bus, right? It's a one-way trip, and you get to do experiments all the way down.